Here's a short video on curvilinear lines in GeoGebra. There was a request for this. In any computational environment, even in Rhino, which is not really a computational environment, there are a lot of ways of doing the same thing. Some are more efficient than others, some are more flexible than others. So just play around and be confident and lean on me if you have any questions. I have office hours, of course. So anyway, how did I do this? Well, there's a couple of ways of doing it. The first is I'd like to perhaps show the base plane so that I could drop a point somewhere over here. I'm going to make another curvilinear wall here. The base plane is found under this icon here under 3D graphics. If you don't see that, there's one of these weird bugs in the program. Sometimes you have to close algebra and then reopen algebra. Certainly in 2D you have to do that, sometimes in 3D. There's three buttons here: the axes, the grid, and then the base plane. So let's just put the base plane on here. And we snap to the base plane if we just drop a point on there. So all I did was I took a point and I just dropped it on there. And you could see that it's glued to the base plane. I can pass a circle using this as the center of the circle, and I will give two other points that are targets, but it's not possible to infinitely move the center of a circle through two arbitrary points, so it'll try its best. So let's see, under that there's a lot of cool circular things in here. So let's do circular arc. And if you ever forget what the commands are, you just wait a little bit and you hold your mouse over there and you see the yellow box. And it's telling you what it wants. Okay, it says select the center and then 2 points. So here's my center, here's 1 point, and here's the other point. Escape, get back to your move thing, and you could see what I was talking about. It's impossible for it to pass through this point, but I actually got really close just kind of accidentally. So this is not super helpful because I really want it to be snapped to this point, but I'm just showing you that. So let's control Z that away here. Another choice would be this incredible command called circumcircular arc. And what it's doing is saying, hey, please select 3 points on the arc, and I'll show you what it does. It's kind of astonishing. Point 1, point 2, and point 3. And what it's doing now, escape out, move a little bit. You can see that it's forming various circles through these 3 points. So this is the one that I really want you to use because we're going to use this in module chapter 5 or 6, maybe 6. Life, if you had my history class, and I know only 2 of you did, I'm very much opposed to circles in structural engineering. Circular shapes are Roman ideas. But for the purposes of our exploration of form, a circle is going to be very close to a parabola. When we have shallow circles and shallow parabolas, they are indistinguishable. Let's just talk about parabolas a little bit in here. Right in here. So parabola says, give me the point and then the direct. Select a point and then the directrix, or a point and the directrix. Point and the directrix. So lots of different powerful tools, but none of them are really, really useful for us in golly, they're pretty cool, but I don't want to do that. That's a Zaha thing here. So I'm just going to get rid of the parent and all the, oops, I don't know what happened there. Okay, so then There's other curves in here. A conic through 5 points is a tremendous tool. I don't use it a lot, but if you had multiple points in here and you really wanted to spline, S-P-L-I-N-E, which is a terrific term, kind of a shipbuilding term that you're bending like a stick into this form. I don't know what the etymology of it, but the word line is in there, S-P-L-I-N-E. So let's try that. Conic through 5 points. 1, 2, 3, 4, 5. Super cool. But as you can see, it forms a complete entity, which is, fantastic for sort of goofing around, but not, again, not really for us for structural engineering. Well, not our structural engineering. This has nothing to do with structural engineering. For architectural engineering, which is form finding, okay? All right, so let's go back to the one that I think you really should do, and that is a circumcircular arc through 3 points. And then what I did was I found the midpoints of the 2 columns here, and I just repeated that. So this is kind of a long video, sorry. I got carried away. And then I drew a perpendicular line through the blue one. And then I drew a parallel plane. I need a plane here. We're going to see how to translate by a vector. If you want to jump ahead, we're going to do this for the tessellation right in here, translate by a vector, but I'm not going to do that right now. I'm going to make a parallel plane right here, parallel plane. I'm going to touch the plane and touch the dot at the midpoint. And now I can intersect the blue plane with the vertical stick. Intersect blue plane with vertical stick. Oops, I made a oopsie poopsie there. There it is. And then one more circumcircular arc. Okay. And then I could hide the plane. Don't delete it, just hide it. Because if you delete the parents, the offspring are dead. Okay, so enjoy that, have fun. See you soon.